Alright, this video talks about problem solving with rational numbers, and we'll look specifically in decimal form today. So we're going to start by looking at adding and subtracting rational numbers, and there's several methods to do this, one of which would be to use your calculator. However, there will be times where you won't be allowed to use your calculator, including potentially on certain tests there might be a section that you're not supposed to use your calculator. So you need to know how to do it without, not just because of that, but it'll also help you think things through and be able to estimate better answers and be able to check more regularly to see if you're getting things right. So this is how you do it in another way, and that is by using a number line. Okay, so before you start groaning, number lines can be very helpful tools in order to help with the addition of positive and negative numbers, rational numbers, on simply because it's tricky sometimes. It gets confusing, and number lines kind of help sort that out. So remember, number line looks something like this. We would have 0 somewhere in the middle, and you'd have your different ticks, right? So if we were going to do a little bit of an example here, you have your positive over there and your negative over here, right? If we were going to do an example, say the example is -3 plus +6, okay? What you do is start your first number at 0, and -3 means we are going to the left 3, so 1, 2, 3, okay? And that would account for the first part. Then we're adding, and remember that the addition of a positive number means moving to the right on our number line, so we're adding a positive number, this time a +6. We're going to move to the right 6 places, right? 6 jumps, so 1, 2, 3, 4, 5, 6. Okay? Notice I started at the point where I left off on the first one, and I count 6 jumps from there, right? 6 jumps. Okay, and that leaves me right here, and if we counted that out, that is a +3, and that's going to be your answer. Okay, if you were given another example here, that we were this time adding a negative number, we're going to see that it goes a little bit different, okay? And we need to make sure we're clear on how to do those types as well. So say you're given a +3 plus a -4. Okay? So if this was your example, it's really the same method, but we just need to remember one thing. So we'll start the same thing, start at 0, go to the right 3 spots, right? And then we're adding, but this time we're adding a negative number. So remember that the addition of a negative number means moving to the left on our number line. So this time, that -4 means we're going 4 to the left. So we start at the end of my arrow where we left off, and we count 1, 2, 3, 4 jumps back. This is where we're, oh, sorry, it's not showing that. 1, 2, 3, 4 jumps back. We end up right over here at -1. Okay, and -1 is going to be your answer. Okay, so hopefully that's a little bit of review, but you see that that number line is very helpful, showing which way you're supposed to go. Now, if you are, sorry about that, if you are asked to subtract a rational number, instead of adding, right, our previous examples always had, we were adding, whether it's positive or negative, sometimes you'll be asked to subtract a rational number. So say you have a +2, okay, and now we're asked to subtract a +4, okay. It is much easier to, instead of seeing this as subtracting a positive 4, to simply switch these signs. It doesn't always work that way. A better way to think of it would be to add the opposite. So the opposite of the positive that we're adding would be a negative. So this instead would be positive 2 plus negative 4. Okay? These are exactly equivalent. There's no difference between them. And if we do that, then we've already done this method, right? It's no different than the methods that we did just right above. Okay, so another example might be a negative 3 minus a negative 6. Okay, again, we see that we are asked to subtract. Okay, so instead of trying to come up with a way to deal with that, we're simply going to add the opposite. So we would write it as negative 3 add the opposite, and the opposite of this negative is a positive 6. Okay, so those would be equivalent. These would be equivalent statements, and again, we know how to do this one on a number line, just like the examples above. Okay, that's addition and subtraction. So use those number lines. That'll help you keep things straight. Now, we're also going to look at, just very briefly, a couple rules that need to be applied when we are multiplying or dividing. So remember, the product, okay, is something, the answer to a multiplication question, and then the quotient is something, the answer of a division statement. Okay, so these rules apply when you're multiplying and dividing, not when you're adding and subtracting. Okay, important to keep that separate. The product or quotient of two rational numbers with the same signs is positive. Okay, and the flip side of that is the product or quotient of two rational numbers with different signs is negative. Okay, you might remember it that if it's the same side or opposites are going to be negative, same is going to be positive. However you choose to remember it, just make sure that you do, because that can obviously have a really big influence on what the overall answer is. Okay, so say an example is negative 3 times negative 7. Okay, well, the signs, we look at the signs, they're both negative. That means that the answer is going to be positive. Okay, then you figure out what the numerical part of the answer is. 3 times 7 is 21. Okay, so positive 21. In the same way, you could have negative 36, okay, divided by positive 9. Okay, we can do the numerical part here first. 36 divided by 9 is going to be 4. Is the answer positive or negative? Well, we look at the signs. We have one that's a negative, one that's positive. Those are different signs, which means that the overall answer is going to be negative 4. Okay, so make sure you remember those two rules for when it comes to multiplying and dividing rational numbers. Okay, and then one last thing to remind you about this order of operations thing. BEDMAS, right? We've done this in previous years as well. BEDMAS is the order that you approach a problem. So when you have a nice complicated problem with more than one operation in there, you are going to follow this order. Okay, so the B stands for brackets. Then you look at exponents. Then the third one would be division and multiplication, and that we see it from left to right, division and multiplication. And then finally, lastly, we would do addition and subtraction, and again that would be left to right. Okay, so you're going to be working on some questions today that will involve several operations. Make sure that you are following this order of operations. If you don't, you'll get some interesting results that unfortunately will not be correct. Okay, hope that is helpful.